A function f is defined by fx is equals to ax cube plus bx square plus cx plus d. Okay, it's a cubic function. The graph of y equals to fx passes through the points 1, 5, minus 1, minus 3. Of course, you can see in the given function there are 4 unknowns a, b, c and d, and of course we must have enough condition to set up 4 equations so that we can use a graphic calculator and solve, okay, to find the values of a, b, c and d. And of course we are given 2 of the coordinates, okay, through which the curve passes. So by substituting 1, 5, okay, into the equation, we can find set up one equation, and by substituting the coordinate -1, -3, we could set up a second equation. Let's say we have got another 2 more conditions. The graph has a turning point. That means the first derivative dy dx should be equal to 0 at x equals to 1, and that should give us a third equation when we use this condition. And the last one is an integral or integration from 0 to 1 fx dx. That means the area under the graph from 0 to 1 should be equal to 6. So if we can set up one more condition, so that should give us the fourth equation. And then using these 4 conditions, we can set up 4 equations and solve them to determine the values of a, b, c and d. Right, and when we do that, we're going to get 5 marks. So first let us copy down the function of x. It's ax cube plus bx square plus cx plus d as given. And since we need to deal with the turning points, okay, so let us differentiate the function and get f prime x. So 3 times a, 3a x squared, plus 2 times b, 2bx, and then we will have a plus c. So 3ax squared plus 2bx plus c should be the first derivative of the function of x. So now we can actually substitute the conditions, and so the third condition is integral of function of x with respect to x. Okay, so I have copied down fx from 0 to 1, and this should be equal to 6. So it's equals to 6. So there we have the third condition. Right, so now we can start to make use of all the conditions to set up the equations. The integral of ax cube, okay, we're going to raise the power 3 to a power 4 when we integrate. So it's going to become ax to the power of 4 over 4 plus bx cube over 3. So when we integrate bx squared term, and cx should give us cx squared over 2, and d, which is a constant, when you integrate it, it's going to give you dx. Okay, and then here we have the limits of 0 to 1, and this should be equal to 6. So we can substitute the upper limit, all the x's, with a 1, and we would just end up getting a over 4, b over 3, and c over 2, and a d. So this is, okay, of course when we substitute the 0, so all the terms are going to become 0, because you know, anything times a 0 is, of course, every one of the terms, as you can see, is going to become 0. So therefore minus a 0, so I am not writing the minus 0, and this should be equals to 6. So we have got a 4, 3 and 2 as the denominators. So we could just get rid of the denominators by taking the lowest common multiple of 4, 3 and 2, which we can use 12. So we will end up having 3a plus 4b plus 6c plus a 12d if I multiply every one of the terms by 12, and 6 times 12 is going to become 72. So there we have the first equation, okay, obtained from the integration. Now let's go to substituting the first set of coordinate. When x is a 1, function of x or the y value is a 5. So we will substitute these 2 coordinates into the function of x. So all the x's, I'm going to turn it into a 1, and then fx, I'm going to replace it with a 5. So of course if it is a 1, 1 times a is a, and then 1 times b is a b plus c plus d, and this should be equal to the value of the fx, which is 5. So there is your equation number 2. Let us now use the third to set up the third equation. Let us use the other given coordinate, which is x is equals to -1 and function of x is equals to -3. So if I substitute, okay, -1 into all the x's, so we can see that the odd powers of x would still be a -1. whereas the even powers would change to a positive. So only the x squared term is going to be a plus b, and whereas this would become minus a, and this will be a plus b, and then we will have a minus c and a plus d, and this should be equals to the y coordinate, which is negative 3. So that's our equation number 3. And now let's use the turning point condition given. When x is equals to 1, the first derivative should be equal to 0, because at turning point the first derivative should be equal to 0. So let's substitute. When x is a 1, x is a 1 here, so it's going to become 3a plus 2b plus c, and that should be equal to 0. So we have this. Okay, so now we have got 4 equations and 4 unknowns. All that you need to do is to key in all these 4 equations into your graphic calculator, and you can find the values of a, b, c and d as a is a 4, b is negative 6, and c should give you 0, and d should be equal to 7. So there we have the values of a, b, c and d, and of course with that value we can now write down the function of x.